Mechanics of solids is an interesting branch of science that studies how different points in the material displace relative to each other, which is nothing but deformation. When a material deforms, it changes the shape of the body, but often it also changes the volume of the body. It depends on the intrinsic properties of the material, whether there is a very large change in volume or if there is a negligible or no change in volume at all. The ability of the material to change or not change its volume during deformation is nothing but volumetric behavior. The materials that do not change their volume during deformation are called as incompressible materials, and the materials that do change their volume are nothing but compressible materials. In general, when a material does change its volume during deformation, not all the deformation results in change in volume. But what do we mean by that? Let's look at the strain developed in the model during this deformation. Typically, the total strain developed in the material is a summation of two types of strains. One component of it results in changing the volume of the body, and this component is called as the volumetric strain. The other component does not result in changing the volume of the body, and this is called as the deviatoric strain. The material tries to resist both the strains. The resistance it offers to the deviatoric strain is called as its elastic modulus, and the resistance it offers to the volumetric strain is called as the bulk modulus. But why is it important to know what each of these strains mean? Well, for one thing, it helps us understand how materials deform, and for another, we can use this information in designing various products. Let's, for instance, look at the bottling of beverages such as wine and champagne. They usually have a wine stopper made of cork material to stop the beverage from leaking out of the bottle. Cork is a special type of wood which is both impermeable and compressible, which means that it does not absorb any liquids and it can change its volume when it undergoes deformation. So this makes cork an ideal material because when it's inserted into the bottle, its total strain is distributed into deviatoric and volumetric strains. And since cork is compressible, it doesn't offer much resistance to change in volume. So there's a good amount of strain developed in the part that's barely resisted. And the best part is that this component is a function of change in volume, which can be controlled by modifying the dimensions of the cork. This makes bottling of wine bottles a fairly intuitive exercise. Similarly, many other applications such as designing footwear or picking a suitable material for engine gaskets or any sealing applications where there's a material deforming in a confined space rely on knowing what percentage of its strain is deviatoric or volumetric. In this section, we'll spend some time to understand how one can decompose the total strain into deviatoric and volumetric components and how it helps us in understanding the properties of a material. In the end, we'll look into a few practical examples to see how this knowledge can be helpful in engineering and other daily applications.